Echo. All right. Okay. Thank you so much, everyone, for coming. And also thank you to the PDS, ARIO, Arweave team who are hosting us here. Yeah, it's really incredible that you guys put these events together year after year. We're very grateful in the community for this opportunity to come together and chat about stuff. It's been a pretty wild week in the Arweave ecosystem. A bunch of stuff has happened. I think today, most interesting thing to talk about perhaps is the core thesis we have about, what would you say, decentralized computation. Essentially, the fundamental theory is that decentralized compute is decentralized data. And what we mean by that really is a derivative of this fundamental observation that deterministic virtual machines plus open and permanent logs just is the same as decentralized computation. So when you think about Bitcoin, a blockchain, right, you think it's like a program. Well, is that actually true? Because when you boot up Bitcoin, what does it do? It downloads data from a peer-to-peer network, and then it validates it, sure. So it's basically just a data stream with validation on the entry into the data structure. And then basically anyone can add to this according to some rules, proof of work, validatable state transitions, basic stuff like this. But fundamentally, Bitcoin is just data. And derivative of that, so when you have this deterministic computation that happens, and Ethereum basically just turned that into a deterministic virtual machine. Other than that, it's the same thing. And you add this open and permanent logs, and both of those systems, Bitcoin and Ethereum, actually essentially all, I wouldn't say all necessarily, but almost all smart contracting systems as they currently exist are essentially just peer-to-peer gossip networks that are trying to keep this piece of state in, what would you say, in the global circulation. And out the back of that, you get what we perceive as decentralized computation. Now, obviously, Arweave is permanent data storage at arbitrary scale. It's just on-chain data that scales to any size. We spent a very long time trying to perfect that design. I think that what we have now, if you've got complaints about it, please come tell me, because of all the stuff I've heard so far, no one has any serious complaints. I think it is a very solid architecture at this point for achieving that goal. Okay, cool. So you've got on-chain storage at any scale. Well, in theory, right, you could have on-chain compute at any scale. Those blockchains are really just data, so why can't we store them? We started thinking about this about 4 years ago. I was quarantining during the pandemic somewhere in an Airbnb in Berlin, and there was a lot of late-night conversations in the team at that time because, frankly, people didn't have things to do. They were just around. And we started thinking about, oh, wait, we have this data availability layer. It's a bit of complexity we'll skip over, but tags in Arweave base layer transactions have 100% data availability guarantees in the same way that you do with Bitcoin. They're circulated to every member of the network. Now, if you have that, in theory, why can't we just represent the virtual machine, the inputs to a contract, and then the program that it's running? Really, this is all just data. And so we started playing with it, and we ended up with this about 150-line JavaScript file. Some of you in the room will remember. Yeah, which was just like a basic proof of concept. And we put it out there on GitHub. It didn't even have a website at that point. It was just like, oh, here's an interesting thing that we think we can do. Yeah, can anyone find a reason this doesn't work? What else can you do with it? And to our surprise, CoinDesk ended up writing about it. That was the first sign that something interesting was happening. We really didn't attempt to gain any PR about it. We just sent it their way, and they just wrote this story. Unfortunately, they called it lazy approach to smart contracts. That was probably unwise branding, but whatever, we come back to that later. And then out of this core idea, and the only other people in the world that were thinking about this particular idea at that point in time, as far as we know, were, funnily enough, what then became Celestia. But at the time, it was called Lazy Ledger. So they also had that bad branding. Yeah, the branding of both has increased over time, I think. It was very uncommon. But as we saw it in the blockchain, what would you say, the crypto ecosystem, if you want to say at large, is this idea of roll-ups has become very popular in the time since then. People have really latched onto this deterministic compute across a verifiably available stream of interactions. And in our ecosystem, of course, and people started writing about it as well. Outprog here from Evervision really, I would say, held the torch for a long time, advocating for why this is the obvious way to make arbitrarily scalable smart contracts. Like, we hadn't cracked precisely how until much more recently, but he advocated for it, and he explained it to people over and over again why this should work and why Arweave was the very sensible home for it. And so soon enough, there were actually 3 different smart contracting ecosystems built on top of the same structure. They're all slight deviations from the original SmartWeave, architecture, basically all adopting something that looks like a sequencer in order to provide data availability, or data publication guarantees, and then Arweave provides long-term storage of the data. And there's something in this, which is when you have things like decentralized databases, they don't interact. So if you have a sequencer writing roll-ups onto Arweave, and you have those sequences of interactions not interacting with one another, you can actually upload as many as you want in parallel. The technical limit is 2 to the power 256 bytes minus 1. Can't put more than that in a single transaction. But that's, I believe, larger than the number of atoms in the universe by some extremely large multiple. So really just arbitrarily scalable. Yeah, these projects here, WeaveDB, First Batch, Quill, they all started experimenting with this for the decentralized database, sector. And they had a very specific use case where their tables and their databases could all be distinct. There was no interplay between them. And that worked really well. So if you look at the decentralized database ecosystem, a whole bunch of those are built on top of Arweave and essentially this core idea already, which was a cool start, I think. But there was a sort of fundamental problem, which is that if you try to expand this out, so you say, okay, I have one smart contract over here and I want it to interact with some smart contract over there. Maybe it's a swap or an exchange or like tokens. Who knows what you want to do with it? Then you start dragging in the state of those other smart contracts, so the roll-ups from these smart contracts into one another until you end up with a situation where essentially everything is dependent on everything else. And you revert back to the scalability of a more traditional system like Ethereum. So that's not good, obviously. We have the core there, right? So for decentralized databases, we can make it so that they can run at arbitrary scale in parallel with one another, all living inside Arweave. That's great. And we can get there also fundamentally because we have lazy evaluation, or what we now call, okay, show of hands. Who likes holographic state versus lazy evaluation? Okay, yeah, it's like vague consensus. I'll take it. Fuzzy consensus is a decentralized network after all. Okay, so we have this idea of like holographic state, something that is projected from data from which you can derive a state that is useful in whatever form you want. So you find out what balance is, how you can swap tokens, whatever it happens to be. And all of that is projected, if you will, from this more 2D plane of just raw data. Okay, that works. We can put many of these things in parallel, but they can't interact that way, right? Like, how can you make it so that these processes can continue to run in parallel? So the computation is happening purely off-chain. That's already a success. That means that you can have any amount of necessary compute power in order to, calculate the next global state. That is already in the bag. You can already store all of the logs that you want to. But how can you make it so that those things can build with each other? Because outside of decentralized databases is a relatively limited set of places that is useful. And so it wasn't long after we first started playing with SmartWeave that we realized there was this opportunity. And that the first time we tried to implement something like it was this thing called foreign call protocol, which I believe, if I'm not mistaken, Tate over there authored. Yeah, which was his first way of passing information around these systems. But again, it entangled them. So we look back to normal distributed systems. Like, how does a normal distributed system operate? You have messages. If you look at the global financial system, it's not like one giant computer where all of the state is shared, which is essentially what, as far as I'm aware, almost maybe every smart contracting system is really shooting for right now, some representation of global shared state. And some of them are very good at it. I actually think the Solana architecture is great for achieving this task. But that's never going to scale to the size that we would want to of a world computer, which was really what sold me on the vision of Ethereum in 2014. God, that's 10 years ago now. Wow. Yeah, that sold me on the vision of that in the first place. You won't be able to do arbitrary amounts of compute in a system like that. So we basically took our cue from the systems that work in the normal, non-crypto environment, distributed systems. We say, okay, forget the idea of global shared state. Let's just focus on having a really killer message bus, a way that you can send messages easily and receive them in other processes inside the system. In fact, let's remove the idea of shared memory completely. Instead, everything is constructed by message passing. And this is very close to how the internet works. Fundamentally, the internet is packets moving around. Those are messages. Or everything that happens in AWS, everything that happens in Twitter, databases in the traditional form, they're all just constructed by messages. And fortunately, with Arweave, we're sitting on top of a fantastic decentralized message bus. Right? It's a system where you put a message in, it's replicated in many places around the world, can't be lost, and subsequently you can pull it into another process and operate on it. That was at least the theory, but it wasn't until about April approximately last year that we really worked out how to do this in practice. And it became what we now call AO for actor oriented. It's the same programming model that the whole distributed systems world has been built on for many years, now just brought into blockchains. And when you get those properties on top of what we already had, which was off-chain computation of state, then you end up with something really, I think is truly incredible. And we launched it this week, and the reception's been pretty amazing, I would say. Something like 1,100 developers started the tutorial in the first 2.5 days, and like 900, 950 to 1,000, they made it out the other side too. So they're seasoned AO developers at this point. Like there's a huge developer community for 2 days. And the whole ecosystem, as far as I can tell at least, is abuzz with like how they can integrate this. And yeah, it's been really incredible to see. It was again one of those moments where we had this idea. We've been working on this for quite a while. It's funny doing that in a vacuum because you don't know what people are going to think about it. We thought we were sitting on something really amazing, but it wasn't until about a month ago that we showed it to people in Arweave, India. There was a kind of community get-together there, and we just demoed it. What do you guys think? And suddenly they started building 3 new projects on top. They're all pretty serious and now have funding. Yeah, then we realized, okay, wow, this is actually something. And then sure enough, when we released it publicly, that's only compounded that belief. So the core features and the way that you get this system to work is that you get rid of every other interaction type. It's just message logs. The whole system is just a massive event queue, if you will. But because of the bundling systems that Arweave uses, this hierarchical architecture where you can plug in any bundler over time, and you can basically fit arbitrary numbers of those bundles of messages into a single base layer transaction. Arweave would work just the same from the point of view of data storage if there was one transaction every block and a block was every hour. It really doesn't matter from the point of view of handling transaction throughput. Yeah, if you get that, then, and you add it with holographic state, you get this single system image, which is this idea, again, from distributed systems, where you can take many computers and turn them into something that looks like one. And the first place that this is useful is obviously crypto. Right? People will want to build decentralized finance applications on this. They already are. And even an agent economy on top of that, which I'll talk about. But we think that the long term of this is it's not completely obvious how much cheaper AWS would be to compute on than this system in the eventual state. And we think that gives us good hope to be able to make decentralization the norm over a very long period of time, not the exception, not something that you do just because you want the extra properties and you're willing to put in the pain of dealing with these difficult systems. It might just actually be full stop easier. So we think that's super exciting. And it gives us what is, it's the first time I've encountered a system like this, which is a decentralized computer in the sense that you can throw in any number of parallel CPU threads and it just increases in power. And each of those processes inside that system can communicate as if everything else is local. There is no distinction between my laptop and your laptop. It's all living in the same space. And we saw this a tiny bit with Ethereum or with Solana, but the cost of interaction and the cost of doing compute was so high that you wouldn't dream of using it for anything other than very minute interactions, basically settlement layer for finance. Whereas this system, you can just throw whatever you want into it. The way that this fundamentally works is that we build 3 additional peer-to-peer networks on top of Arweave. They're all intermingled, but they basically separate out into messenger units, scheduler units, and compute units. And then essentially what happens is when you send a message to this system as a user, say I want to transfer a token to Seb over here. Okay, so I send a message to the token contract. I say the recipient should be Seb, the quantity should be 1. And I sign this as the user, and I send it to a messaging unit. And the messaging unit passes it to the scheduling unit. The scheduling unit is responsible for ensuring publication to Arweave, and also for giving it a unique, monotomically increasing timestamp, or nonce, if you want to call it that. Basically a way of saying this, for this process, it is number 5 in the sequence. And then that blows that to Arweave. Then the messaging unit would go to a compute unit of its choice. And you can just, because these are peer-to-peer networks, you can just plug in more compute units. Like really, it's a simple off-chain demand and supply marketplace for computation. If more people want compute, then great, the prices actually go up on the CUs, the CUs. But that also brings an incentive to bring more compute units online, bringing the price down. It's an efficient, simple peer-to-peer marketplace, yeah, for buying access to compute. So you'd ask the compute unit of your choice, hey, what was the outcome of this interaction? And it would say, you got 2 new messages. One message to Seb that says credit notice 1, you got 1 new token from this address, and 1 notice to me that says debit notice, you gave away 1 token to Seb. Okay, cool. So we get those messages, we bring from the compute unit to the messaging unit signs both of them, attesting to them essentially, and then it pushes them around again to the schedulers. And it just asks again, hey, what was the output of this? And maybe Seb has something on his personal process in AOS, super simple to build, that says, oh, when I receive a token, actually take that to Bark and immediately swap it for, I believe that, yeah, the mem crew announced last night that they're going to build a wrapped USDT on AO. So swap it for wrapped USDT immediately. So I don't hold any, I was about to say unstable tokens, but then I remember how many times I've seen Tether depeg over the years. So not quite stable tokens, but whatever. That's Seb's preference. Sorry, Seb. Okay, and yeah, and so those interactions in the system, they keep being pushed around by these messaging units until it's complete. And in this way, anyone can interact with these processes and any other processes in parallel at the same time. More demand for messaging, compute, and even scheduling units just brings more of them online. One of the coolest moments in the testnet was when we moved from having 3 scheduler units to, if I remember correctly, 100 or 200 in one day, and absolutely nothing broke. Funnily enough, nobody noticed because the architecture actually works. And those scheduling units weren't at capacity, so it just seamlessly increases in capacity. Having worked in distributed systems for a long time, that's magical. It's really very exciting. And then, of course, on top of all of this, the messaging unit is attesting to, I promise that this is the message that's passed around the system. And the compute unit is saying, I'm promising that this is the output of the interaction. And indeed, the scheduling unit is saying, hey, I promise that I'm going to get this onto the network at a certain, with a certain set of attestations. All of this can be secured by a proof of stake system that sits on top, where you stake tokens, and then you can be slashed for misbehavior. And some of that is like Ethereum style. So basically, it's actually quite an interesting system. You might want to call it like mutually assured destruction. In the Ethereum system, and basically every proof of stake network, you could, in theory, just have everyone gang up and vote against other people. It's not cryptographically validated state transitions. They are vote determined. They're economically secure state transitions, which is very different than what would happen in Bitcoin. So what happens with those stakes is essentially the result of the crowd, which is, I think, an underappreciated or under concerned about situation. So in the case of at least these scheduling units over here, you can actually start to enforce cryptographic behaviors upon them. And the things that we might want them to do is say, okay, you must publish the attestation that, hey, this is number 5 in the sequence, as well as the data itself. But we can actually make it so the scheduler unit, I don't know if we do this in the spec right now. The spec is in draft. We're still working on it. But you could certainly make it such that it returns to you the signed attestation saying, I promise that this is going to be number 6 in the sequence. And that means if the scheduler doesn't publish that, the messaging unit can publish it. Anyone can publish it. But say somehow that gets lost too, you can go to the staking contract and you can say, hey, I can't see number 6 in the sequence. And if the scheduling unit doesn't come back and say, here it is, and that's a cryptographically verifiable state transition in some period of time, then we slash the stake. Same for censorship. If the scheduler tries to censor you, you can say, they won't give me an attestation for this transaction I want to process or this message. And okay, you just post it to the staking contract or a sub-ledger of the staking contract. And then if they don't come along and give it a sequence number and they sign that and put it into that contract itself, then you can also slash them. And there's a couple more like this. So you can get like proper cryptographic security guarantees around the scheduling units. And then the other components work more Ethereum and Solana and I think pretty much every proof of stake system where what happens with the stake of the other stakers is determined by the staker set themselves. Okay, so that's the broad architecture. And then that's like under the hood. If you lift it up, turn over this laptop, unscrew the back, and you see a motherboard, that's basically the AOS or AO motherboard. But from the perspective of the user, it looks more like this. The user sends a message, it gets pushed around the system, the scheduling unit pushes it, and then they get a message back from the coup that says, okay, here's what the output was, and then they basically just get a result out the end. And the nice thing here is that this, from a UX point of view, is very simple. What's happening under the hood is relatively complex, but from the UX point of view, you just sign your message, you send it, then you wait and see what happens, and then you read the result at the end. Okay, so yeah, I said there's been like about 1,000 developers, as far as we can tell, that tried the tutorial and sent messages to it. 278 or 76 today, and I think it's 500 on day one. Yeah, nearly 1 million messages passed in the system, and perhaps the coolest part, I think, is 371 parallel processes executing today alone. That's 371 rollups. Anyway, I'm just super excited about this technology. We think that the end game of decentralized compute is a single system image for humanities compute. Imagine AWS, but there was an efficient market for decreasing the prices rather than a monopoly effect. And anyone can spin up processes inside, and it's literally like you're all sharing the same giant computer. And everything is local. There's no difference between the processes you started and processes other people started. You just send messages between them as if they were on your local machine. It's what they've been trying to build in distributed operating systems, which was the PhD I was working on before starting Arweave. They've been trying to do this since the 60s. And all of those systems, these are the ones that I saw, were permissioned. So to add more compute, to add more capacity to this, they had to be running under the authority of one person. So you could build a supercomputer. In fact, distributed operating systems were essentially created so that people could use supercomputers. But 10 people in the world had access to it. Here we have something that goes way wider. Like you can fit arbitrary amounts of processes inside the system, arbitrary amounts of hardware, and anyone can access it. And there should be an efficient market for the price at which you access it. Again, I'm just very excited about this. Any number of processes, any amount of hardware, no local or remote, one computer. This is the core idea of, I think, where AO goes long term. And so you can see it in practice. The DataOS crew very kindly made a block explorer. Funnily enough, decentralized ecosystems being what they are, the day of the launch, about 20 minutes before we were supposed to go do this live event, which maybe some of you heard through the hot mic, whoops. Yeah, it turned out that 2 people in the ecosystem had both built block explorers called AOScan. One was aoscan.io, one was aoscan.xyz. This is now called AOLink, thankfully, but the ViewBlock team also made one. It's called AOScan. It's pretty cool. But here you can see how the messages move around the system. So you can get this, and we're going to label each of these arcs so that you can understand just by looking at it intuitively, oh, I see, someone sent a broadcast message to this chat room, and then it sent a relay of that message around to a bunch of other people. Like, it's very intuitive to use because there's a word for it, but it died out in the 60s, it's symbolic computation. This idea that you basically label the stuff that's happening, and then when you just read the logs back, what occurred is just in plain written English. Yeah, it has those properties as well. But forget the long term, the short term. What do we need to do now? I think the most important thing is to spawn an agent economy. And so, yes, Solana is a very well-engineered piece of technology. It seriously is. I know that lots of people hate it, but I don't know that many people that hate it have actually looked into it. So I would challenge you, if you're one of those crowd, go read how it really works. It's quite a smart machine, but it will only scale to the edge of a box. Essentially what their network is doing is it's saying, let's have one globally shared memory space, and then that computer that is controlling it, if you will, actually for that period of time, cycles around the world in many different places. AO is radically different. There is no globally shared memory space. You just have local memory, and then you use a message bus for interactions. And what that means is we can do crazy amounts of compute inside a single one of these processes. Like you can build agents inside it that do heavy AI workloads inside a smart contract and then execute upon them. And the obvious thing that leads to long term is the creation of, you call them agent funds, but that would be the start. So a central observation here is that 70% of NASDAQ trades originate from AI agents already. When you think about the global economy and you think about markets specifically, what are they actually doing? There's a settlement layer, right? There are these fundamental finance primitives. I take a loan, I repay the loan, right? And we call it a mechanism design. It's a game, if you will, even, that we've decided to play together. And it has these concrete actions. But what I see when I look at the price of Tesla or Microsoft is I see something very different. And maybe even loans also from the Fed or from different businesses. It's all the same, with the underlying mechanism being different. But when I look at the prices, I'm actually looking at decentralized intelligence. Right? So there's 70% of the trades that are happening with these aren't even coming from humans. And so what you see when you see that price is you're seeing the average, in some sense, a weighted average, of the opinions of many different intelligent systems. And in DeFi, so far, it's just a settlement layer. It started, okay, you could debate this. Did DeFi start with Bitcoin? I don't know. But it's a payment system, first of all, right? So you settle the payments from one person to another. But why are those payments happening? Because there is a market intelligence around the edge of it that is leading people to engage with the system. They're incentivized to engage with that system. But we settle the payments on chain. You could say the Bitcoin economy is doing something, it's doing all sorts of different things in different markets. But the price of Bitcoin is some sort of global estimation, approximation of what we all actually believe that Bitcoin should be worth. Something like that. And sometimes you think it's too much, sometimes you think it's too low. It doesn't really matter. But by looking at that one number, you're seeing the output of an intelligence. Whereas DeFi, so first it was payments, then it was swaps. On Uniswap was the first big one. Okay, cool. So I can put in some tokens, I get out some other tokens. Again, it's just the settlement layer. Why am I swapping those tokens? The market has a decentralized mind, if you will, that's making this happen. It's incentivizing people to take part in these games. All of that is off-chain. I think that's the past. I think that the DeFi was the settlement layer, but it can actually be, it can be the whole machine. It can be the intelligence of the markets on-chain. And one of the most interesting things we've seen in the really early days, or literally like 2.5 days, I can't remember how many days since Tuesday, it feels like a lifetime. But like in the first few days, it's people playing this game called AO effect. And basically what it is, you can spin up a node or a process, and you can do it with your hand if you want. You can interact and you try sending messages around and getting your processes to attack one another and blow each other up in the silly arena. But you can also build agents. And we spawned it with a bunch of basic agents, and now people are starting to build new agents that are smarter, and they're competing with one another to gain each other's tokens. And so today it's a silly game about blowing each other up, but tomorrow it will be markets. And the intelligence of these systems will be on-chain itself. And that will mean that you can do things like have trustless execution of those intelligences. And then you, with your intelligence, can decide which of those, would you say, strategies, basically, you want to employ. And so the strategies in the market come on-chain in the same way that the settlement layer did. And I'm no longer distracted by X when I'm trying to get other things done. I'm now distracted by AO Link. I like to look at all the eval that people are doing. I was just clicking random ones earlier, and I came across this. Someone's making some kind of blackjack game inside the system. Again, starts with simple, we'd say non-economic games, although all of these are betting tokens, so I guess that makes them economic. But where it goes long-term, it's very obvious it's just an economy. So we really think that, I don't know what the right name for this is. Some people are saying AI-fi, some people are saying agent-fi, something like this. But the intelligence of these things will live on-chain, and you will be able to put money into strategies that execute intelligent ideas for you. And it's not just, what would you say, basic strategies. They can do things like ping an oracle. There's this thing called Orbit that launched. Actually, as one of the people that we met at this event in Arweave India went out and built this thing. It's an oracle, but it's not just bringing you like crypto prices. It's bringing you full HTTP results. Anything you want from the open web, it'll pull it on-chain. That can be pulled into your smart contract if you want, or your verifiable process, and then you execute upon it. Okay, I see this headline from the New York Times. I think oil prices are going to go up, and that means that I'm going to go do these trades in the network. They can be very intelligent strategies. And a cool thing about this, if you're just into Arweave as like a, let's say, settlement layer for history, that's an interesting one. Yeah, Arweave as a record of history and knowledge, then an amazing thing that this will do is it will bring the signals that are important to these AI agents into the network themselves. And in doing so, it will make them permanently available. It'll grow the archive. And that's amazing. It'll be skewed towards finance stuff to begin with. In fact, you could argue we already have this. Like there's God knows how many Oracle uploads by Redstone on top of the Arweave system. That actually has like the history of crypto in some form inside the network. But that was for use inside other systems, other smart contract networks that can't deal with big bits of data. Imagine if we had that, but it's not just crypto prices, it's all of the news that was relevant to the markets on that day. And we just build up this log over time, we'll get a good record of history, and it's incentivized. People have this selfish incentive to execute these archiving bots now, which is cool. All right, TLDR, I'm like super hyped about this thing. I think it's an amazing machine, and I'm very grateful for the reaction that people have had in the community to it. I don't even know what the time was. I'm not sure if I'm over or under. Anyway, yeah, if we have time for questions, I'll take some if you want to, or yeah. Yes, very good point. Yeah, one of the exciting things we did here is we didn't start building until we actually knew how to do it. Which sounds stupid, but the whole of crypto starts building stuff at random before they know how to solve it. It's Ethereum, right? So the data protocol underneath in that specification, we think is pretty robust. We might make a few tweaks here and there, but I really don't expect it to change massively, unless someone finds some fundamental flaw with it, which is always possible. But yeah, as far as we're aware, the data protocol is pretty good. The implementations of those coups, moves, and SUs, those subnetworks, there's a lot of work to do there. They will improve for many years, I think. You're most welcome to, yes, please. We should talk afterwards. Yeah. We're actually about to fund some of those. We think that like particularly the coups, this is a bit in the weeds, but basically what we have right now is a hypervisor written in, of all things, JavaScript. It's not an appropriate way to build a hypervisor. You can make that far more efficient. Yeah, we think Erlang there. Oh, and I don't know if Eraser is here. Eraser from 7x, I was chatting to him yesterday. He had a great idea, which was what if we let people parallel mine Arweave and AO at the same time? And so I think we can actually build at least compute units into something that you can merge with an Arweave miner. Then you're running both at the same time. And yeah, you can offer your hard drive space. You can also offer compute. Because most of these miners have a bunch of compute available as well. So that will instantly unlock a huge amount of compute. All right. Thank you, everyone.